cell phone database. So only disconnect for half a minute in the future, not like a 5, 7, 10 minutes. I was trying to reconnect. Actually, it's an internet company problem. Okay. Let's start class. Yes. I look at the problems you submit through emails, and I organize those problems. I also know what's going on here. I will begin with that basically the problems belong to two categories. One is about geometry, okay? The other one is about usually like a maximum minimum value problem. Okay, maximum minimum problem is always an issue. So we can spend a little bit more time on those. Okay. Geometry. Okay. Almost. Okay, everybody have a problem with the last one. Number 30. Okay. Now, to solve this type of problems, what kind of knowledge we need? Okay. I want to go over that first. So if you have a triangle, okay, it's called triangle area comparison theorem. Okay, if you have two triangles, if they have the same height, okay, this is A, that's a B. If the same height, H, okay, the comparison area, okay, A, B, C, it's A prime and B prime and C prime. We assume that they have the same height. If they have the same height, then the ratio of the area, A, B, C, okay? First of all, let's do the computation. How do you do that? Half of A times H, half of the B times H, right? Then one half canceled out, H canceled out. So what you get is just the ratio of the bases. Okay, that's our formula. You know, you can memorize it, but you should know why this is true. Okay. Where we can use it, so we begin with this first problem. Okay. You have two triangles, A, B, C, D, right? So if if this side is 5 square centimeters, you want to know what is the area of the other side. But also know the base, right? So this side is 5, that side is 4. Okay. 5 cm, 4 cm. What you should do is, you should know that those two triangles have the same height. Okay? Those two triangles have the same height, so the area of the triangle ADC divided by the area of the triangle ABD is going to be 4 over 5. Okay? But we know the area of ABD, right? So that's 5 then. So this is already equal to 5. Then the area of triangle ADC is going to be 4 over 5 times 5. That's a 4 square centimeters. That's the easy part. Okay. This is the first problem. The second problem for practice is it's not given directly. I just say here's an equilateral triangle. Okay. If this is a 1, 1, 1, and this is a 2, right? So find the area of the triangle ABC. Okay. It's the same idea because you know the area of this equilateral triangle. So the area of ABC is double of the equilateral triangle just because ABC, right, is going to be doubles the area of the equilateral triangle is twice of the area of ABD. And I know the area of the equilateral triangle. Okay, so that's going to be square root of 3 over 4 times 1. Okay. Let me go back. What's going on here? Okay, let's go back. I think I touched the file. All right, so the area of ABC is going to be twice, actually 2 over 1 times area of ABD, okay? And we already know the area of the equilateral triangle, so that's our answer. All right. All right, we continue to do the next problem. Okay, if you have a triangle and you randomly draw the point here and you pick up an arbitrary point, okay, and you connect it, okay. Now, if I can write down, yeah, this is like a 2 square centimeters, and this triangle area is 3 square centimeters. That's a 4 square centimeters. What is the area of that triangle? All right, so this is a little bit more difficult, but you should know that this actually consists of 2 triangles share the same vertex. One is this, okay? Another one is this. Okay, this is 4 square centimeters. That's okay. If I decompose them into 2 parts, you probably know how to figure it out. Okay, so this area called A, and I don't know the sides, but I know I'm going to use A and the B, these 2 sides. So 2 over 3 is going to be the ratio of their corresponding bases. But this is also A, that's also B. So that's going to be A over 4. Okay, A over 4. Then A is going to be 2 over 3 times 4, which is going to be 8 over 3 square centimeters. Okay, that's good. Then I'm going to talk about similar triangles. Okay. Similar triangles, I have 2 triangles that are similar, that look similar, right? One is A, B, C, and A prime, B prime, C prime. Okay, so similar means A, B, A prime, B prime over A, B should be equal to B prime, C prime over B, C should be equal to A prime, C prime, AC, right? And that's called constant. This is a ratio. They're all the same. What we should know is the area, the ratio of the area, triangle ABC is going to be K squared, because area is always square, you know. And why this is true? Why this is true? That's obvious, but how do you prove it? Okay, how do you prove it? Well, you have to draw a height, okay? Because those 2 triangles are similar, then and this is called H. That's H prime, okay? So these two triangles are similar, okay? These two triangles must be similar. Therefore, H, okay, H over H, H prime over, yeah, H prime over H is going to be the same fact, K. Okay? Because why it's same fact K? Because it's going to be A prime and B prime over AB, okay? Because those two triangles are similar, you use the one side, right? H prime over H is going to be A prime B prime over AB. We already know that A prime B prime equals K. So that's enough. Then the area, you see that the area is going to be, what? It's going to be half of B prime C prime, right? Times H prime. And this half of BC times H. But each of them gives you K times K. That's why you get K squared, okay? So this is important, yeah. Sometimes, you know, the height is not given there, then as long as they're similar, you can get this ratio, okay? The ratio of the area is going to be K squared. It's reasonable, but here's the proof, okay? You still use the original formula, the base times height, okay? The ratio of that base is still K. The ratio of the height also should be K. So that's why K times K equals K squared, right? So here's a problem. Let's trapezoid. And here's nice whatever uses unit. Okay, so square centimeters and 25 square centimeter. Right? So I want to find the area of this. So let's use B, C, D, and E. Find the area of AD. And then add them together, you get total the area of ABCD. That's a trapezoid, right? Now, sometimes it's easy to find the last one. Why? Since you know there's a definite answer, so if this is not the way we want to live, but if this is on the math competition, you know the answer is definite. Okay, the rest should be a number for the answer. So but the picture looks very arbitrary, but you just you can make a right triangle to figure out the answer, a right trapezoid. Okay, you can assume that both sides are identical. So how do we do this problem? Okay, you can just figure out the answer. You can do the quick way, the shortcut. Okay, so you assume the trapezoid is a right trapezoid. So you assume that it is the right. It is a right trapezoid. Right trapezoid means that both sides are equal. Right trapezoid looks like that, and even you can assume that yeah, it's a right trapezoid, right? It goes like that. So that means both sides are equal, right? Okay, put it this way. Then you're trying to figure it out. So how can you do that? If you assume both sides are equal, and this side I call the X, other side is the Y. Okay, square centimeters. this is also y is the same. So because it's a, you assume they're the same, right? Only have one variable here. What you should do, you do the same way as we did for the last problem. Yeah, we did this problem, right? We did this problem, right? Yeah, very similar idea. So you left-hand side, I over x is going to be, if this side is little a, this side is little b, it will be a over b, right? But then you use the other two triangles, you will get x over 25. Okay? Then we what? Then you get x squared equals 9 times 25. And that's the reason why I use the 9 perfect square here, because we want to have a perfect square. So 3 times 5 squared, right? So x is going to be 3 times 5, it's a 15. So x is a 15 square centimeters. Then if you assume it is a right trapezoid, then the both sides of the triangles have the same area. It's a 15 square centimeters. And then your answer is total area. You know, if you just want to find the total area, is going to be 9 plus 25 plus 15 plus 15, okay? And which is going to be 64 square centimeters. Okay, so you get the answer right away. You know the answer is definite. And there's a number for that. Then you just look at the special special picture, okay? So you can figure the answer. But your question still is, do you know, those two triangles in general have the same area or not? They look different, definitely, okay? So in general, okay? And can you figure it out? So it could be looks like that. Right? They look completely different. And here's 9, here's 25, and that's called x and y. Okay? This is a problem, right? So in general. Okay? I don't know. Okay. All right, so we let's do the problem. Okay, I think we can figure it out. A, B, C, D, E. Okay, this is a E. A, B, C, D. Okay. I still do the comparison at the same idea, and use the two left triangle. I get by the area comparison. Okay, so I get by the area comparison, okay, theorem. So I get 9 over x equals 9 over y over 25. All right. So the problem is x times y is going to be 9 times 25, which is 15 squared. Since I don't know whether y equals 5, right? I have a problem here. Okay. So let's go back to here. There is a key issue we haven't used it. Have we used these two lines of parallel? No. Right? That's the reason we only get one equation, because this could be like that even, right? Okay, still you have the same equality here. If it is 9, and it's not necessary, it's not necessary to be a trapezoid. Could be even like that. Okay, if this is 25, right? You still have this identity. Think about it. You haven't used a trapezoid condition, two lines are parallel. Yeah, this is still true. If here's x, here's a y, right? 9 over x, and then you have in the middle, this is a A, that's a B, right? And then this is going to be A over B, the ratio of the bases. Right? And then use the other pair of the triangles, you get a y over 25. Of course, you did not use the A and the B. So that's the reason you cannot figure it out. You can only get one equation. If you want to get another equation, you have to look at how can I use the trapezoid condition. Okay, so trapezoid condition, okay, this is a trapezoid. So this angle equals that angle. Here's alpha. And that beta equals that beta. Okay, so this is A, B, C, D, and E. So what does that mean? That means the top triangle is similar to the bottom triangle. So the triangle ABE is similar to the triangle CDE, okay? But these two sides are same, corresponding to each other. Okay, it's a switch. These two sides are corresponding to each other. That's good. That means the ratio of the area, you can use it because those two triangles are similar. So the area of triangle ABE over the area of the triangle CDE is going to be, I know it's going to be 9 over 25, right? But this is going to be A over B squared. Okay? So A over B squared. Because that's the ratio of their sides of the two similar triangles. Oops. Okay? So actually A over B is given. It's going to be 3 over 5. That's good enough. Okay? Then you go back to what did you see here? A over B is 3 over 5. Okay? So 9 over x equals 25, equals y over 25. Okay, equal y over 25 is going to be 3 over 5. Okay, we already got this is A over B. So from here, actually, you can get x. X is going to be